Hi, I'm Joe James. In this video, I'm going to explain the difference between a shallow copy and a deep copy in Python. And I'm going to walk you through a series of examples in a Jupyter notebook that explains exactly what the differences are between the various different methods of making shallow copy and deep copy. There are a variety of different ways of doing that. And this series of examples, as usual, I'm going to post all the code on my GitHub site. You'll be able to download the Jupyter notebook and run the code on your own. But we'll look at both objects and integers and lists of objects and lists of integers, and you'll be able to see how each of these methods works with those different data types. So in the first example, you need to understand that assignment is not a copy. We have list A equals 2, 4, 6, and then a sublist with 1 and 3 in it. And we'll use this same example list throughout all these examples. But if we set list B equal to list A, all that does is creates another reference to the same list called list B. It doesn't create a new list, it just creates a new reference to the same list. So both list A and list B both point to this list. You haven't created a copy at all. So this is just assignment, right? The equal sign is just an assignment. It's not a copy. So if we set list B of 1 equal to 44, what that does is changes both list B and list A because there's really only one list. And in these examples, I'm going to print out the ID so that you can see. The ID is basically the memory address for that element. So when we run that, you see that the list is indeed changed. We print out list A. You can see that it is changed. A 44 is there. And both of them have the exact same memory address for list A and list B. So they both point to exactly the same list. Okay, so if you want to make a shallow copy, there are a few different ways to do that. Here's probably the most popular one. You just call the list constructor by calling list, and then in parentheses you passed in some sequence of items. In this case, we already have a list called list A. And it will create a new list called list B that is going to be, it's going to have the same elements as list A. Now what you'll find here though is that this is a shallow copy, and what that means is that if you have native data types like a 2, 4, 6, okay, these are integers, or you have floating point values or strings, it will indeed make a copy of those. So you can change those in list B and it won't affect list A. However, if you have a sublist, basically list A has a reference to this sublist and list B has a reference to the same sublist. So it doesn't make a deep copy. This sublist is the same in both lists. So if you make a change to a sublist item in either list, it's going to affect the other one. So that's called a shallow copy. So here we set list B of 1 equal to 44, and when we print out list A, you can see that that didn't affect list A. But when we set list B of, this is a 2D list, right? Element 3 is this sublist, and element 0 is the 1 there. We change that to 55 in list B. Guess what? You print out list A, that also changes it to 55. So that's a shallow copy. It doesn't copy the second level elements of the list. And there are other ways to make a shallow copy. Like I said, you can use the list constructor like this. That's one easy way to do it. I think that's probably the most intuitive way. You can also use a list comprehension. That's what we have here. So we use a list comprehension, iterates through the items in list A, adds each of them as a new element in a new list, and assigns that to list B. However, this sublist is really, it's going to have list B and list A again are both still going to have the same reference to the same sublist. So this is still a shallow copy. List comprehension is one way to do it. You can do list A.copy. That's another way. And then you can use import copy and then list B equals copy.copy. This is a nice little copy function built into Python that copies not only lists but other stuff too. So that's another way to do it. I'll run each one of these and you can see what they look like. So when we change element 3.0 in list B and then print out list A, you see that, yeah, that element is changed. Same here because we also get a shallow copy. And same here because we also get a shallow copy. So these are different ways to make shallow copies. If you want to make a deep copy, what you need is to actually copy each one of the elements within this list to a new list. And the way to do that in Python, the easiest way to do it is with a deep copy. So we already imported this copy function, so copy.deepCopy, and then we pass in list A. That will make a deep copy, which means that it will actually make a new copy of this sublist. So when we make changes to items in list B, even the sublist in list B, it doesn't affect list A. So when we run that, you see list A is unaffected by changes to list B, even the sub-elements. So that is a deep copy, and that's how you make a deep copy in a Python list. If you want to take a look at objects, we can create a class called Pony, a simple constructor with the pony's name. So I have 3 different examples here, and in the first one, you can use copy.copy on an object, and that will give you 2 unique objects, and they'll each have different IDs, right? So let me run these 3 examples so you can see. In the first example, you see that they have different IDs because we used copy.copy on an object and it actually created a new object with a new reference to it. Okay, so you actually do get a deep copy of that object. If we use copy.copy on a list of objects, however, it's going to give you 2 unique lists, right? We get references to 2 different lists, but they contain exactly the same objects. So if we print the ID of M0 and N0, the 2 ponies, pony 1, pony 1, they're actually both the same object and they have the same reference. So we have 2 different lists, but they both contain exactly the same object. So if you make changes to either one of those 2 ponies, you change pony 1's name, it's going to change in both lists. So this is not a deep copy. Copy.copy is not a deep copy because we have a list with 2 objects in it and we use copy.copy. That makes a shallow copy. So if you want to deep copy objects in a list, you need to use copy.deepCopy. Similar with integers, right? You use copy.deepCopy, you pass in one list of objects, and Python will deep copy those objects and create new ones. And then you can see that when we print out the ID, the memory address of M0 and N0, they're different because now we have unique objects in each list. I hope this video is helpful for you. If so, please click the thumbs up and subscribe to my channel. I'm Joe James. Thanks for watching.